All right. So hi everyone. For anyone watching this video, just wanted to get on here and make a video kind of going over the week one content. So unfortunately for those that attended the meeting, again, sincerely apologize that I was having technical difficulties, but from here on out, I won't have those. So like I said, my sister was having her baby unexpectedly that day. So I was back home and definitely my iPad and nothing seemed to be working, but I'm back home now at my house, so we should be good now from here on out. So look forward to seeing you all for week 2 on Thursday 6 to 7. But with that, I'm just going to kind of share my screen and do what I would have typically done yesterday. Also, there is a video link you should see for you probably don't have to watch this if you've already if you attended, Thursdays, because I did kind of give an overview Thursday on how the course works, but I do have another video that's about 10 minutes long that explains how the course works. So definitely watch that if you need to, and again, reach out if there's any questions or concerns or anything. So with that, I'm just going to share my screen and go from there. Actually, share my screen this time. Okay. All right, so you should see my screen hopefully at this point. I don't have anyone to tell me if it's working, so I'm just gonna assume it is here. So again, I just wanted to go over that week 1 content, and I'm gonna put this in the slideshow view and go from there. This week's pretty short. I had a pretty short PowerPoint to begin with, but so at the basics, again, just like ELT 120, we are talking about electricity and what it is. One thing you'll notice is that the definition of electricity changes. There's just it's such a fundamental piece of science, and something that can be described in a lot of different ways and in a lot of different contexts in particular. So the definition that I'm giving here might be a little different to what you've heard in ELT 120. It doesn't mean both will work definitions of electricity, but again, just the context is different here. But some of it might be kind of repeat. So basically, electricity is formed by the imbalance of electric charges. So in ELT 120 and 106, we talk about the atom and how there's protons, neutrons, and electrons. Those electrons are what carries that charge. That negative charge, and then the protons carry the positive charge. So it's the imbalance of electric charges, typically from the negative side there. So the electrons that essentially creates electricity. So that a movement of electrons around is what's generating electricity, which kind of makes sense. Electrons, electricity, they have the same base word there. So electricity, it can produce light, heat, motion. So you can think of like lightning is essentially a form of electricity. It's just, a natural form, static electricity. And then we have, like electrical current. So think of like an outlet or a battery. So there's kind of 2 different sides of electricity there. Then voltages are important too when talking about electricity. So we really talked about those a lot in ELT 120. But basically, voltages cause that charge imbalance that can cause electrons to move through a conductor from a region of more negative charge to a region of more positive charge. And again, that's referring to this movement of electrons. So this power source here, is the battery, and the battery has the voltage, and that voltage is what's creating that charge imbalance, which makes sense if you look at the voltage of this battery here. We have a positive side and a negative side, indicating that charge balance there. So kind of read this diagram here. So electricity is the energy that comes from the flow of electrons. So that power source provides that steady flow of electrons. And again, the electron, they call it here a tiny piece of electricity, if it helps you think about it like that. And then that whole electric circuit that we dealt a lot with in ELT 120 is just, where we have our power source, we have our electrons moving along it through like a wire or some form of media. And then they typically hit some something to operate that circuit. So in this, most of the time it's a light, and when we're doing, just generic circuit drawings. And basically this whole circuit can cause this light bulb to light if operating effectively. So this is where this class kind of takes a turn, and something that we really haven't touched much about in any of the electrical courses you've taken here. So now we're going to start to talk about magnetism, which, is exactly what you use when you were kids, the little magnets that, were attracted to each other on one side and repelled each other on one side. So basically it's a physical phenomenon that is created by moving electric charge. So it is related to electricity right there by moving electric charges. But a couple of difference here is that one, a magnetic field can induce charged particles to move, which creates an electric current. So that's kind of, again, another way that these two are related. Another component that's important here is, like electricity, that's related to attraction or repulsion of our objects. We have the negative positive charge. We have that in magnetism. However, this time in magnetism, we don't have positive and negative charges. We have the north and south pole. So, and that's just because, the magnetism is related to the Earth's magnetic field, which, again, if you've ever had any, science courses when you were little talking about magnets, they always talked about that north and south pole and how, the south attracts the north repels the north. So, similar to positive attracts negative, we have the attraction and repulsion of objects that is really the physical phenomenon that kind of shows just the significance and impact of this principle. So this is something just important to note, that magnetism is still the repulsion of objects or attraction of objects, just it's north versus south, not positive versus negative like electricity like we're used to. Then it's just also important here to kind of highlight some of the ways that these two words kind of are connected. So we're also introduced to a couple new terms here. And again, if you have never heard of these terms before, it's totally okay. They're, terms that we don't hear a lot, don't use a lot. So they're supposed to be new, but we have the term magnetic flux and flux density. So magnetic flux, when we, essentially this here on the right, I should say this first, is a picture image of, a magnetic force field. So we have our north and south poles, right? And then you can see all these arrows that are kind of showing the attraction. So the north to the south, you can see that all of them are going from one side to the other, indicating that, attraction from one side to the other. So magnetic flux is just however many lines of force are flowing outward from the magnet's north pole. So you can see here that in this example, we have 6, right? We have 1, 2, 3 here, and 1, 2, 3 here. So 6. You wouldn't count this side because this is one continual loop. So 1, 2, 3, and then on the bottom here, 1, 2, 3. That's what magnetic flux is. And then flux density just means how close those lines are. So are they really, close like this, or are they, spaced out like this? And it should help you remember that, because density, that's what density is, right? So something that's more dense holds a lot of matter. So whereas something that's less dense doesn't hold a lot of matter. So it makes sense that something that has more flux density has more lines. It's got more of a force in there. And then the number of Maxwell's is just the number of lines. So Maxwell's is used as a unit for magnetic flux. So that's denoted here by this mx, which we already talked about as 6. And then, and I kind of alluded to this, but the higher density, flux density you have, that's stronger the magnetic effect. And again, that just makes sense because high flux density means we've got a lot of lines going through there, and they're really close together. So they're really compact and strong. So we're also introduced to this simple equation. It's a lot simpler than some of the equations we've dealt with in ELT 120. So basically magnetic flux, which defines the amount of magnetic field, which is measured in Tesla, which travels perpendicular to an area A, where A is just, the letter used to denote area. So in this example here, we have like areas maybe measured in meters squared. So in order to find the magnetic flux, you can take B, which again is Tesla, and multiply it by your area, which hopefully is in meters squared. So that's all this page is saying. Just B times A equals, I think this is theta, but this technically is just magnetic flux. And again, the units here are Weber. Well, I guess not again, I don't think I've said that, but I think it's there, however. Okay, so finally, we already kind of tied both of these words together, but I just wanted to touch on, excuse me, I just wanted to touch on electromagnetism. So basically, electromagnetism is a magnetic field that is created by the flow of electric current. So the more currents in a wire, the stronger that magnetic field. So electromagnetism really is the same definition of magnetism and electricity. It just is, explaining how to talk about both of them. So the longer wires you have, or the more coils in the wire, equal or lead to more magnetism. And we know more magnetism leads to more Maxwell's, which means we have more lines of flux. So this bottom here is just showing, kind of, if you have longer wires, this is that you're eventually getting to more lines of flux. That's what that is showing. So, essentially, that's going to change a lot of like your values when you're doing calculations. And we'll talk about in weeks to come, like how coils in a wire, this comes into play a lot, how that can kind of play a role in some of your calculations you do. Okay, so the last thing I think this is the last thing I wanted to touch on. So in these two videos that you can watch if you want to, I would highly recommend it. This bottom one here just explains magnetism, and I think it's really interesting. And this top one here explains the difference between a motor and generator from an energy standpoint. And it's talked about in the videos, but I think that this YouTube video does a great job at visually showing it. So basically, when we're dealing with electricity, we're essentially dealing with electrical energy. And you may know that energy form, has a lot of different forms. So we have electrical energy, mechanical energy, solar energy, and, energy can never be created or destroyed. It can only change forms. And a lot of times this form is off as heat. But which is why things get really hot sometimes, electrical components, because that's how it's transferring that energy. But basically a motor and a generator work really similar, but completely opposite at the same time. So essentially what the video shows is how a motor is converting electrical energy into mechanical energy. So you can see that these dashed lines here are essentially like the force field that's causing this in the middle here, the shafts to move because of that force field. So this force field in itself is electrical energy, and it is creating something to move, and anything that moves is mechanical energy. So like a wind turbine is a form of mechanical energy. We're throwing wind at a turbine and it's causing it to move, which is creating mechanical energy. And if you're wondering, well, then isn't that an example of creating energy? No, because wind is moving, which is a form of kinetic energy. So I guess I should say mechanical energy is a form of something moving, like a physical component moving, whereas kinetic is the act of it going. So I guess they're kind of similar, but again, so that's just kind of what this side is. And then a generator does the exact opposite. So it converts mechanical energy to electrical energy, kind of in a similar way of using those poles, but it's starting with something moving and then using this machine here to kind of to transmit or transform that mechanical energy to electrical energy. So again, mechanical energy is just a machine or mechanism moving, and electrical energy is not something you can physically see, but they're both really useful in modern day society. So definitely give that video a watch. Well, both of them, I would highly advise it. With that, I'm going to stop sharing and just say, for anyone watching this, I hope this was helpful. Again, sincerely apologize about Thursday, but I will be on it on next Thursday. And you have to reach out. You have my email if there's any questions or concerns. I'm here to help. And hopefully we have a great semester. And look forward to working with you all. I've had a lot of you before, but if I haven't had you, welcome, and definitely reach out if there's anything I can help with at all. But thank you.